Alright, so this is going to be a video on taking the derivative of the natural log function. Um, and there are a handful of ways to do this. I know of three. I'm going to show you two because the third one um, just so happens to require something on the very next page of my book, which uncomfortably I haven't learned yet very well. So I'm going to just hold off on that. Um, so I'm going to show you these two ways which I'm more comfortable with. One of them is really easy. One of them is a little bit more difficult, but they both work. They both get the same results. So whatever works for you, I guess, whichever one you like more, you can use. So I'm going to start off with the easier one here. So the easier one is basically just starting off with y equals the natural log of x. Let me write that a little bit better. That didn't come out very well. Okay, y equals natural log of x. Okay. And then what we're gonna do is I don't know what this is called literally, but we're just making them both bases, or well, both powers of e. If you do know what it's called, please tell me, because I'm always at loss for words when I see it. I just know it works because you're doing it to both sides, and it is what it is. Anyways, though, now we're gonna differentiate both sides here, and I'm just gonna write d over dx of e to the y equals, and these cancel here, and we're just going to be left with x, and the derivative of that is 1. Just a quick side note, the reason these cancel is because they are inverse functions. We have e e to the x, and we have natural log of x. Um, what a natural log is asking is it's basically a special logarithm, right? So a natural log is asking, what do we have to raise e to? What are we raising e to get x? That's what it's asking. What do we have to raise e to get x? That's what any log is asking, just with different bases. So whatever that is, whatever that value is, that's what this is going to give us. Let's say that it's equal to z for some reason, right? Just some random variable. If we have e to the natural log of z, or e to the natural log of x, and whatever that this is equal to is the power that you raise e to get x, and we're making that the power that we're raising this e to, then this must equal x, because that's the entire idea behind the logarithm, and because they're both inverses, and that's how inverses work. So you can think of it however you'd like, but that's the main idea. And then, of course, I took the derivative of that, which was 1. And then I'm moving forward. I'm going to use the chain rule on the left-hand side, and I'm going to say e to the y, because the derivative of e to the x is e to the x, and so we have our exterior function here, e to the x, and then we're inputting our interior g of x or whatever. And then this is multiplied by d over dx of y, which is our interior, equals 1. Moving forward, we can just say e to the y equals, or e to the y times dy over dx equals 1. And we're going to divide both sides by e to the y to isolate this right here, because that's what we're solving for, the derivative. So we're going to have just dy over dx equals 1 over e to the y. And then you may be wondering, okay, what do you do next? Well, if we look earlier, e to the y is equal to e to the natural log of x, as we see right here. We use this. So I can just rewrite it as that. But I also know that this is just equal to x, as I showed earlier. So I can just say that this is equal to 1 over x when I just skip that step. Okay, so make this a little bit cleaner. I'm going to put it in the corner. 1 over x. Okay, so I'm going to put this in like the corner or something, because now I'm going to show you the other proof. So let me just clear the rest of this. Okay. So the other proof involves a theorem and I'll just write it out for you here. It's d over dx, the inverse of f of x equals 1 over f prime of inverse of f of x. And you kind of need to know this for this proof. It's the underlying part of it. If you don't know it, go ahead and look into it. If you prefer that I explain it for whatever reason, let me know and I'll do it my best. I'm just not proving it right now. Anyways, though, if we're going to use this here, let's just go ahead and get started with it. So in this case, we are solving for the derivative of the natural log of x, which happens to be the inverse of e to the x, so keep that in mind. So if this is equal to 1 over f prime must be e to the something here, or x, because that's what the derivative of e to the x is. It's e to the x. And e to the x is the inverse, so that's why I'm putting it here. That's where that's coming from. So we have e to the something, and that something is the inverse of e, which is the natural log of x, since it's this and this are the same thing. So now I'm just going to input natural log of x. Hopefully you see where this is going. And so as I showed you earlier, e to the natural log of x is just going to be x, and we get this 1 over x again. So that's just another way to show it. Obviously, one of them's, in my opinion, easier than the other, which is going to be this one, but whichever one you prefer, or whichever one you have to learn. So to give you a couple examples of it, I'm just going to put this in the corner like that. Okay. Let's say we want to find the derivative of the natural log of 5x squared plus 3. Okay. What does that equal? Well, this is going to obviously involve a little bit of the chain rule because you can see it's a composite function. But for our first bit here, we can say that it's 1 over 5x squared plus 3 because the derivative of the natural log of x, our exterior, is just 1 over x. And this x being inputted is 5x squared plus 3. And then we're multiplying that by 5x squared plus 3, or well, the derivative of that, which is going to be 10x plus 0. So it's just going to be 10x. Okay. So then we have 10x here, and then I'm just going to say 10x. That'll get us 10x over 5x squared plus 3. And that's, I believe that's as simplified as it's going to get. Okay, so yeah, that's basically all there is to this. It's not too complicated. This is used a lot. And when I do learn the next bit, which is, if I didn't already say it, it's the literal definition of E, is literally on the next page. I'll make a video about that in a little bit. I guess covering it and explaining it intuitively to the best of my ability. Hopefully it will make sense. And then after that, I may be able to show the proof of the natural log of x using that new bit of information. So that would be the third way of proving it that I didn't show this time.